We'll start with the leading cause of death in the United States: heart disease. Heart disease refers to conditions that impair the function of the heart or blood vessels. Heart attack and stroke are two of the most serious forms of heart disease, but are often preceded by other conditions such as coronary artery disease and vascular disease. We need our heart to pump oxygenated blood through our blood vessels and to pump deoxygenated blood back to the lungs to get fresh oxygen. Why is this so important? Our cells need oxygen to perform the basic metabolic processes that provide them with energy. When cardiovascular function declines, the body doesn't get the oxygen it needs, leading to progressive or catastrophic health issues. Heart disease manifests itself in many different ways, but there are typical trends that occur with aging. In general, the aorta, the main artery that carries blood away from your heart to the rest of the body, becomes less elastic in older hearts and does not let blood pump as efficiently. This leads to elevated systolic blood pressure, the primary cause of hypertension in older adults. Hypertrophy, or thickened heart muscle, leads to heart failure, another consequence of aging that makes it tougher for the heart to beat efficiently. Atherosclerosis is probably the most common and the most familiar manifestation of heart disease. In atherosclerotic blood vessels, buildups of fats, proteins, and cholesterols can slow or even block the flow of blood. Heart attacks are caused when the vessels supplying the heart itself become blocked. There are many known risk factors for heart disease. Smoking, for example, increases your risk by more than 60%. But this pales in relation to aging, which increases your risk by 10 times as much. That's by more than 6,000%. How does aging influence the development of heart disease? In truth, almost every hallmark of aging will be present in aged heart tissue. But there are some specific hallmarks that show up in both lab and clinical studies as being particularly at play. Deregulated nutrient sensing is associated with cardiac hypertrophy. Increased signaling from mTOR has been implicated in accelerated cardiac aging. In mice, treatment with rapamycin, which inhibits mTOR, prevents heart disease. Older cardiac cells show evidence of mitochondrial dysfunction and increasing production of reactive oxidative species, also known as free radicals. The increase in these unstable molecules can lead to runaway cellular damage and declining heart function. Over time, the proteins that support the heart are not regularly recycled, a consequence of impaired proteostasis. This causes the heart muscle to become more fibrotic and stiff and less efficient at pumping. The production of the hormone angiotensin II increases with age, an example of altered intracellular communication. This increase is associated with more fibrotic heart muscle and weakened heart function. ACE inhibitor drugs are known to block this damaging increase in angiotensin II. And finally, the heart has a limited pool of stem cells that decline in regenerative capacity with age through stem cell exhaustion. The good news about heart disease is that much of it is preventable. Remember that aging is a risk factor, but there are plenty of people who live very long lives without serious heart problems. While there are some genetic predispositions toward atherosclerotic plaques and other cardiovascular issues, lifestyle choices have a big impact on overall heart health. Not smoking and increasing exercise are two of the best choices you can make to reduce your risk, no matter how old you are.